and welcome to space here from the Atacama Desert in Chile, a place which is so clear and so dry that it's already special to astronomers. And now European scientists have chosen it as the place to build the world's largest ever optical and infrared telescope. We're going to find out how it's done, but first some more news from the universe this month. ESA's Bepi Colombo mission to Mercury is a step closer to launch in 2016. The spacecraft, built in Italy, will now face final heat and vibration tests in the Netherlands. A team from Poland, Germany and Portugal have built and tested a quadcopter drone as a new way to drop rover robots onto the surface of Mars. And a new mission to study black holes has been accepted by ESA. The Athena Space Telescope will watch as material is sucked in by gravity. To our main story now, and the first step in building this new telescope is to blow up the top of a mountain. This remote area of the Atacama Desert in Chile is famous for nothing. No water, no plants, no animals. And that makes it the perfect place for a truly groundbreaking project to build the E-ELT, or European Extremely Large Telescope.
The reason we're blasting the top off the mountain is to make way for a structure that dwarfs anything we've ever built before.
Dos, uno.
Probably from here, 25 kilometers away, it appeared. But we were blasting 5,000 cubic meters of rock, something like 11,000 of tons of rock that went into the air.
The rocks in question are here at the summit of Cerro Armazones. This 3,000-meter mountain will soon have a 150-meter diameter platform at its summit. There, the European Southern Observatory will build this, the E-ELT, as tall as a football stadium with an enormous 39-meter mirror.
Build it, do it, make it available for science. That's my role. We are really in the middle of nowhere. We have to create the road, we have to create the platform, we have to create anything in order to host the platform. Difficult to manufacture the pieces in Europe or wherever it will be. Different to transport here, long chain of containers of pieces. Manufacturing here on site, dry, very dry, lot of sun, radiation, and then integration in, on the top of that mountain.
If it's so remote and inaccessible with a landscape that looks more like Mars than Earth, why did ESO choose to build its massive new telescope here?
We spent a long time investigating which of the mountains have the clearest skies, which of them have the most cloud-free nights, which of them have the least twinkle in the sky. This one came out on top, and that's why we're building the telescope here.
The E-ELT will be operated from ESO's Paranal Observatory, 25 kilometers away, a desert oasis that featured in James Bond film Quantum of Solace. Quiet by day, it comes to life at dusk, as the VLT, or Very Large Telescope, opens to the skies and the astronomers get to work.
We're at the control room of the Paranal Observatory. This is the place from where we run the telescopes.
Each night, these astronomers work here collecting data for scientists in Europe, observing everything from distant galaxies to planets in our solar system. And while the VLT already offers them a powerful tool, the E-ELT will be a game changer.
There are stars that we can actually detect just from barely detect from space or from the ground. We can never take a spectrum with what we have now. With the ELT, we'll be able to do that. We'll be able to do so many more things. It's just hard, it's breathtaking.
So how does the E-ELT compare to the finest telescopes in space? Machines like the joint ESA-NASA Hubble have an uninterrupted view of the universe from orbit. And what's more, like its successor, JWST, it can see wavelengths that we can't see from the ground. But the E-ELT will gather more light and see sharper detail.
In certain areas, space is very important to observe what we call the thermal infrared, for example, and space is very good for observing in ultraviolet. But there are areas where we can observe in higher resolution from the ground. We can use different techniques, different areas that I wouldn't say are in competition, but are complementary.
Many astronomers will be using space and ground-based data to complement each other. That's what they're doing now as well. People are using data from the Hubble Space Telescope, finding very faint objects, and then going to the VLT in order to take a spectrum of it.
Some of those very faint objects the astronomers are looking at are in fact planets orbiting around other stars. These exoplanets will be a key target of the E-ELT when it's built in a decade's time.
One of the main developments in astronomy over the last 5 years has been the discovery of an enormous diversity of exoplanets. We now know that they look very different from maybe our Earth or Mars or Venus or Jupiter. And so what the ELT will be able to do is characterize these planets. Now we only have hints at what their nature is, but the ELT will really be able to measure their atmospheres and see what they are made of.
We will be able to image planets going around other stars for the first time. We'll be able to determine whether they have any signs of life. And of course, in the context that we live our lives, that will change everything. It'll be a different world, knowing that we're not alone.
The quest for life elsewhere goes on, with space and ground telescopes soon joined by the E-ELT here in the almost lifeless Atacama Desert. All year we're following ESA's Rosetta mission as the team hunts down a comet and puts a lander on its surface. Let's see what's happening. Today on Comet Hunters, Jake and Armel are in the clean room at ESA's Operations Centre in Germany, testing commands on an exact copy of the Rosetta spacecraft.
While Rosetta is flying far away, we have a fully functional model here at ESOC that we can use to test out various things that we want to do.
We have a full suite of instruments on Rosetta that allow us to observe the comet from a distance, to look at it in UV and infrared, etc.
There will be things coming off the comet, but that's also the point for some of the instruments because a lot of them analyze things as they impact the instrument. Science is already underway. In fact, one of the instruments, Miro, has recently detected water on the comet, so that's a pretty big thing for us as well. So we're getting there. Dear Rosetta, just a couple more maneuvers. You're almost there. We can't wait to see what you're seeing.
That's it for now. We're just going to enjoy the view and we'll see you next time.